So basically, so far, we heard a lot about how to create a good citizen science project. My study is more how to use data coming from good citizen science project. So I'm looking really more how to use them for creating rabbit distribution across Australia. So the presentation today is going to go basically giving you a background idea of my project and why I came from the idea of using citizen science data for mapping the distribution of rabbits in Australia and where the objective of the study. I'm going to go rapidly also on the methodology behind it and give you some preliminary and expected results, as unfortunately I'm a PhD student, a bit late on my project, but I'm trying to catch up and I have some just first results for you. And what are the next steps, basically what I'm doing over the next few weeks. So rabbits have been introduced for a couple of years in Australia, and we do understand what are the impact they have on biodiversity and how detrimental they are for the environment. There's about 300 studies that have been conducted on rabbits over the last 50 years, which is a lot for one species. However, even though 300 studies, most of them have been concentrating on trying to understand what are the best management plans for controlling the population of rabbits, looking mainly on diseases such as calicivirus and rabbit hemorrhagic diseases. But few of them have been looking at what are the conditions that influence the distribution of the rabbits, which is something usually you try to answer, especially if you try to manage population throughout Australia. So this is where the idea of compiling a large data sets that collect all the information that I have on rabbits over the last 50 years came on. And this include over 100 of studies, and every of the data sets that we collected, we pair it with environmental and climatic data, try to see which conditions influence where the rabbit is being observed in Australia. And the aim of it is really to try to get a continental trends of where to find the rabbits. So collecting hundreds of studies, of course, we're collecting different type of data sets, so a wide diversity. We had data coming from biologists and expert managers, but we also had data coming from museums and also from state-based collections, and data coming from citizen science programs. So this is where citizens come in here. And all of this data, including expert data, also include observation bias. And this is where we struggle sometimes and where we do a lot of modelings as where to use or not to use citizen science is the observation bias that comes with it. And this is, for a good example, if you take the Atlas of Living Australia and you plot the maps of where the species are present, you're basically able to see where Melbourne is, where Sydney is, where the main road is. So where people are going more is where we tend to see more observations. And we also have issue with reporting biases. So sometimes people report more animals than other people, so we have issue of effort management. And for this project, we decided that some of the actually citizen science data are really well conducted, and they could actually be included into what we consider expert data. So we redefine it, create new definitions of the data set we're using. We use targeted data and non-targeted data. So targeted data are all the projects that have been simply according to a field protocols, which is scientifically based behind it, with specific objectives. So these data tend to be quite reliable. Whereas non-targeted scientific data, non-targeted science data are those data we consider more as opportunistic data. Basically, when the apps that you have on your phone and you go around and you basically, oh, I spotted rabbits and I just report it back. So this is mainly the case, for example, feral scan that we use commonly across Australia. So the first objective was basically to understand, are we able to use opportunistic data alone to create a distribution of rabbit across Australia? What will be the effect of the sampling bias that we observed? And otherwise, can we also include the data to our more targeted data sets as to increase our knowledge about the different conditions under which the species is present, and to try to fill out the blanks as where we don't have proper science studies have been done, because it's really hard to get data from all across Australia, and then where citizens' observation could be quite useful. So the models I'm using are species distribution models, and this is where sampling bias come really into consideration as an important issue with the data sets. As as a summary, rapid summary of how species distribution models works, is that you provide a set of presence point and a set of absence point. And you extract for each point the information about climatic and environmental variables behind it. And for example, these are the ones I'm using for my models, so those that are biologically significant for the species. Then according to statistical behind it, like a mathematical formula, you create a formula that is able to produce, to determine which range of condition under which the species is observed and which is not for all of these variables and the combination between the variables. And it's quite big, but don't worry, the computer is doing most of the work. And at the end, you end up with a map of habitat suitability, so basically telling you where is more likely to observe the species and not. So the idea of my project was to compare different type of different species distribution models. So using data that are only from targeted fields, data that are only from non-targeted data fields, and combining both of them together and to see what, at the end, how it differs and how we may be able to correct it. So I'm using also 4 different types of models. So GLM, which is general linear models, GAM, BRT, and Maxent. So different type of algorithms, because different algorithms work differently with the sample biases. Some works better, they don't have issues with them, but some have more issues. And it's really interesting to see, are those models that are easier to understand the one that works the best or not with sampling bias and the data. And then I needed to provide methods of pseudo-absence. So we call it pseudo-absence because, as most of you understand, maybe, we don't have absence point of the rabbits. If we do, it's really hard to be reliable on them because you need to prove on many years consecutive that the rabbit is obviously absent on one point. Whereas if you got only observation points, if they say, yeah, I didn't see any rabbits there, it may just be because the rabbit wasn't there that day. So we needed to create what we call pseudo-absence. So we decided to take 4 different ways of creating those pseudo-absence. The traditional one is to create it randomly throughout Australia, which is basically comparing a set of perfect distribution against a set of really precise distribution where the rabbits are present. But we also decided to try to restrict where in Australia we can generate those pseudo-absence to only regions where the species is able to survive biologically. So trying to really promote the difference between the conditions where the species is absent and the species is present. And then we decided to do, well, what about if we try to correct for sampling bias using pseudo-absence? So we decided to create an intensity map that you see on the right. So try to highlight areas in Australia where we have the most data set, and then just generate pseudo-absence having the same bias. So comparing bias data with bias data pseudo-absence, and eventually correct the models doing that. So 48 different set of combinations in total to see how non-targeted data can be included. And then to test it, well, we decided to test it using different model predictive skills, which are commonly used in species distribution models. But we also wanted to see if a model could be good, but does it interpret correctly the biology of the species, and what is how influence of one variable comparatively to the other one, and one model's comparatively to the another set of models. So like I said, it is a work in progress, but I do have a bit of pictures I can present to you today. So these are the results from the GLM, so quite simple species distribution models for the targeted data. So a bit what we consider sometimes expert or scientifically biased observations. So the higher the value on the left is, the better is the model. What we can observe rapidly here is that the models where we try to restrict where the pseudo-absence were collected works worse than the models where we just generate pseudo-absence throughout Australia. And the idea behind it is maybe that just the rabbits is so well spread that the models, if we provide a greater range of environmental variables under which it is calibrated, it works better. So, well, that's a good thing. That's 2 less models for me to work for the next ones. But then the interesting fact is that if we look the black square, which is data that have been randomly sampled across Australia, and the green square, which is data that have been weighted, try to correct for bias, they both work similarly. And that was really interesting. But considering that on the right, this is the sampling intensity that I obtained for the targeted data, you could see the sampling intensity is quite widespread. It almost covered the full Australia. So if we consider all the expert data, we don't have any difference that much. And this is why maybe data that being generated throughout Australia is similar to data that being corrected for that case. Yeah, thank you. And then we expect then, if we consider the combined data set, where you see the sampling intensity on the top right is quite similar to this. We expect that, well, in the case of rabbits for GRM, it will give the same results as in the case of targeted data. But maybe the model's going to be just better. The variables are just going to be better and predict because we have more data sets into it. But we don't need to correct for it. So this is our questions that need to be answered. But then, if you look on the bottom right, this is the intensity sampling for non-targeted data. And you could see this, in that case, there's really like specific regions and northern territories and in southwestern Australia where there's really specific area where more observation were provided. And then in those cases, we do expect that we may be able to see differences. And I really wish to be able to present a graph of that result today, but their models are still running. So that's going to be in the next presentation. So we expect that models that being corrected for will actually do better than models that are being randomly sampled. So just in a general overview, I just generated models from targeted data using GLM and their 4 combinations. But we do see already that the choice of pseudo-absence may influence the models, and this may be a way to correct the biases, and maybe we don't need to correct the biases if we consider the other models. So take-home message, it is a work in progress. The results, I hope, will provide really important information at how we can use those opportunistic data because they are easy to collect and they do provide more information that we're able as just expert data. So keep an eye on my work and eventually maybe see you next conference with all the results.
Thank you. We've got a couple of minutes. Do we have any questions for Emily? Anyone? Thank you very much, Emily.